Hi friends, welcome to our lesson. My name is Mrs. Gradney, and today we'll be expressing metric capacity measurements in terms of a smaller unit, and we'll be solving addition and subtraction problems involving mixed units. Let's get started. Here I have a beaker. The beaker shows liters on this side and milliliters on this side. Find the mark on the beaker that shows 1 liter and point to it. Here's the mark that shows 1 liter. I'm going to pour water into the beaker until it reaches 1 liter. Watch. Now, how many milliliters are in the beaker, and how do you know? 1,000 milliliters are in the beaker. And we know because if we look at this side where it says 1 liter and then slide on over to the other side, we can see that it says 1,000 milliliters. So we can write that like this. 1 liter equals 1,000 milliliters. Now notice how I abbreviated milliliters. I used a lowercase m and a capital L. You might also see milliliters abbreviated this way, with a lowercase l. Both of these ways to abbreviate milliliters are correct, but in this lesson, you're going to see us use it this way with a capital L. And you'll also see it written this way later on your problem set. Now, I'm going to pour more water into the beaker to measure 1,500 milliliters. Watch. Okay, so we know there are 1,500 milliliters in the beaker, but how many liters are in the beaker? We can see it's more than 1 liter, but less than 2 liters. There's 1 whole liter and then 500 milliliters more. Just like we could name mixed units with kilograms and grams in our last lesson, we can use mixed units of liters and milliliters. So we can write 1 liter, 500 milliliters equals 1,500 milliliters. Now I'm going to pour water in the beaker to measure 2 liters. Watch. Now, how many milliliters are in the beaker? 2,000 milliliters. So we can write 2 liters equals 2,000 milliliters. Now I'm going to pour water in the beaker to measure 2,250 milliliters. Watch. Now, pause the video and discuss the capacity of the beaker. You may have said the beaker is not yet at capacity because there's room to pour in more water. Capacity is how much a container can hold. The capacity of this beaker is 3 liters, and right now it only has 2 liters, 250 milliliters in it. If we were to add 750 milliliters more of water, then it would reach capacity. Now let's practice reading some capacity measurements and recording them in both mixed units and in milliliters. Pause the video, read the beaker, and record the measurement in mixed units of liters and milliliters, and also in just milliliters, and write it in an equation like you can see here. Then come back and we'll compare. Hopefully you read the measurement correctly and wrote 1 liter, 250 milliliters equals 1,250 milliliters. Let's try another one. Pause the video, read the beaker, and record the measurement in mixed units of liters and milliliters, and also only in milliliters, and write it as an equation like this. Come back when you're ready to compare. Hopefully you read the beaker correctly and got a measurement of 2 liters, 750 milliliters equals 2,750 milliliters. Now let's apply what we're learning about mixed units of capacity to solve an addition problem. This will probably remind you of what we learned in our last 2 lessons. Let's read this addition expression together. 32 liters, 420 milliliters plus 13 liters, 585 milliliters. How can you use what we learned in our last 2 lessons to help you here? You may have noticed that in this addition expression, we're adding mixed units. And even though the units that we're looking at here are liters and milliliters, we can think about this problem in the same ways that we solved the problems in our last lesson with mixed units of kilograms and grams. So, would you use an addition algorithm or a simplifying strategy to solve this problem? Pause the video to think about it and explain what you're thinking out loud. Maybe you said that you'd like to use an addition algorithm because the numbers are so large. Or maybe you said you want to use a simplifying strategy because you noticed that 585 is only 15 away from the next 100, and that would be a friendlier number to work with. Or maybe you said you want to try a simplifying strategy, but then you want to go back and check your work using an addition algorithm. All of those are great ideas. So choose the way you want to solve this problem now, and pause the video and solve it. When you're done, come back and we'll compare our strategies. Welcome back. Hopefully you found the sum was 46 liters, 5 milliliters, or if you solved in milliliters, 46,005 milliliters. Now here are 3 different ways that you could have solved the problem, though these are not the only correct ways that you could have solved it. Does one of them look similar to how you thought about it? Pause the video now and analyze each of these solution strategies. See if you can explain out loud what the strategy was. So, how did they solve in solution A? In solution A, they used an algorithm. But first, they converted the mixed units to milliliters before adding, and then renamed again in mixed units at the end. Solution B also used an algorithm, but what's different? In solution B, they left the add-ins as mixed units. So they added together the liters first, and then they added together the milliliters, and then they renamed 1,005 milliliters as 1 liter, 5 milliliters using a number bond. Solution C used a simplifying strategy. Why in solution C did they decompose 420 milliliters as 405 and 15? They decomposed 420 milliliters as 405 and 15 because they could put these 15 milliliters with the 585 milliliters to get to the next 100, 600 milliliters. 405 plus 600 is a lot friendlier to add mentally than 420 plus 585. Let's try a subtraction problem now. Let's read this expression together. 12 liters, 215 milliliters, minus 8 liters, 600 milliliters. How might you solve it? Using a subtraction algorithm or a simplifying strategy? Pause the video to explain your reasoning. You may be thinking of using an algorithm or a simplifying strategy. Choose the way you want to solve the problem. Pause the video now and solve it. If you want to challenge yourself, try to solve the problem in more than one way. When you're done, come back and we'll compare strategies. Welcome back. Hopefully you found the difference was 3 liters, 615 milliliters, or if you solved in milliliters, 3,615 milliliters. Remember, expressing the measurement in both ways is correct. Here are 4 different ways that you may have solved the problem, but of course, remember, these aren't the only correct ways that you could have solved it. Do any of them look similar to how you thought about the problem? Now, let's analyze these solution strategies. Pause the video to analyze each of the solution strategies and explain out loud how the problem was solved in each of these ways. In solution A, how is the problem set up? In solution A, they used an algorithm, and they renamed 12 liters, 215 milliliters as 11 liters, 1,215 milliliters. Then they continued to regroup as needed to subtract. How is solution B set up? In solution B, they also used an algorithm, but this time they renamed those mixed units into milliliters before subtracting. But then at the end, they wrote the difference using mixed units. Solutions C and D both use a simplifying strategy. In solution C, why do you think they renamed 4 liters into 4,000 milliliters? They renamed 4 liters into 4,000 milliliters because they needed to subtract 600 milliliters. And they couldn't subtract 600 milliliters from 215 milliliters. So converting 4 liters to 4,000 milliliters allowed them to subtract. Solution D used a counting up strategy. How did that counting up work? To count up, they started at 8 liters, 600 milliliters, and added on 400 milliliters to get to the next liter, which was 9 liters. Then they continued to add on liters and milliliters until they got to the total of 12 liters, 215 milliliters. Then they just added up all of the liters and milliliters that were counted on. Great job today, friends. I think we're ready for our problem set. On the screen are the must-do problems for the problem set. Set a timer or watch the clock for 10 minutes to work on these problems. Of course, if you have extra time, feel free to try any of the other problems on the problem set as well. Today, we expressed metric capacity measurements in terms of a smaller unit, and we solved addition and subtraction problems with mixed units. Remember to check in with your teacher, and I'll see you next time for another Eureka math lesson. Bye!